So welcome panelists, welcome attendees. We are here with the 6th edition of our Unmasking Plastics series. Today we're talking Remake It, looking at alternative materials, alternative non-petroleum plastics. And we have 3 really interesting companies with us today working on very different approaches to new materials and different market segments. So without further ado, I'll hand things over to our guest curator, Patty, who will take it away.
Yeah. Hello, everyone, and thank you very much for joining us one more week. And one more week that is actually so interesting. And we have, as Ron said, we have 3 amazing new material innovation for this week's seminar that will substitute, hopefully, single-use plastic pollution. And I think that there is no one better than themselves to explain what they do and why it's so important, the work that they're doing. So please, David, John, and Jeff, could you explain in 3 to 4 minutes what you're doing and why it's so impactful for the rest of the world? Could you start, John? Yeah,
I'll kick it off. No, thanks for having me, guys. My name is John Feltz. I'm the co-founder and CEO of Cruise Foam. And at Cruise Foam, we're really passionate about the oceans. That's really kind of where this company came and really kind of started from, is the enormous amount of plastics we saw entering our oceans every year. Just was atrocious, and something we thought there had to be a better solution for this. And so we really developed this technology from this enormous demand that we saw coming from the industry for a need of sustainable packaging solutions that could really service as protective packaging and really start replacing, these plastic foams like EPS, like EPE. There's approximately, I'd say, about 8 billion plus of this packaging purchased every year. And we're really trying to tackle and service an industry that still uses an enormous amount of this, specifically kind of electronics and appliances, and really offering that protection that we don't see a good replacement for EPS as a sustainable solution. And so Cruise Foam itself, we really combine a pretty diverse set of expertise in bioplastics, manufacturing, engineering, design. My background's in chemical and materials engineering. I spent about 6 years as an environmental engineer working in industry. My other co-founder, Marco, is basically an expert with the material we use, chitin. And we use this chitin to basically create a biobenign, all natural packaging solution that we've really positioned to be produced at scale with existing industry. We want to see this be really scalable and reach cost parity at low volumes. And as I said, we're really targeting that tertiary packaging, the protective packaging. And what kind of makes our product unique, besides using the second most abundant biopolymer on the planet, chitin, we've found a way to really combine other waste streams. We're really targeting recycled paper, starches, low-grade fibers, things that we can really tune the performance, the aesthetics, the cost, and really provide solutions for a wide range of customer needs. And as you know, we don't do this with any harsh chemicals. There's no petroleum-based additives, there's no VOCs. And we're really focused on trying to reduce the resources we take from this planet, focusing on waste streams. And the technology we've developed is really positioned in a way that I've touched on, that we want to see it scale effectively with industry that we know wants this type of solution. So we've developed extrusion technology that can drop in. We're talking to partners now, and we really want to see this be a global solution, really have the impact to just start displacing EPS on that type of volume it needs to be in packaging. And so for us, we're at a point where we've been working with Fortune 100 companies, and we're looking to service North America, but as I said, this is going to be global. And so we're definitely seeing the regulations and the consumers push, and we want to be there to service it for the planet.
I will come back a little bit more with the regulation and other things that you will come later on. So thank you very much. Jeff, would you like to introduce your company, please?
Happy to. I'm Jeff Anderson. I'm the co-founder and external co-CEO of Full Cycle Bioplastics. We invented a technology that converts organic waste. And when I say organic waste, I mean anything that degrades naturally in the environment. So food waste, agricultural residues, papers, anything that goes into a compost row or an anaerobic digester. And we convert all that into a bioplastic called PHA. Much more specifically, we make a PHBV blend. But what that means is it's effectively a biobenign plastic alternative that can be used to replace polypropylene, polyethylene, and polystyrene at large scale. We've been doing this for about 8 years, and I founded it with my fraternal twin brother, who is my co-founder and internal co-CEO. We're different than others in the sense that we are actually a circular plastics company. We can actually take our PHA after it's gone out into the market and then come back at its end of life, where it goes back into the organic stream and it breaks down just like food waste or just like the other organic waste into the basic building blocks and gets built up into virgin PHA again. So we're actually able to organically recycle or upcycle our plastic, hence the name Full Cycle. Why us? So my brother and I founded this when we were body surfing in San Diego. We are big ocean lovers. I'm a scuba diver and a body surfer. And we always used to get hit in the face by plastic pollution. So we're uniquely situated with our engineering background and our love for the ocean, which is great. And then in the United States here in California, which is where we are, there's a lot of compost infrastructure already in place and organic separation. So we actually are poised to plug right in at those compost facilities and landfills to actually start really running that circular model along with some of our large partners.
Great. I will come back a little bit more about what is PHA in the following questions, but thank you very much for the time being. David, could you please explain what Everywhere it's doing?
Yeah, thank you. Hi everyone, my name is David Christian. I'm a founder and CEO of Evo & Co. So it's a pleasure to be here, especially with Jeff and John. I know you guys have a really good products that maybe we can collaborate as well. Yeah, so basically, Evo & Co, we have a vision that we want to create a world without plastic pollution. So in the first brand, under Evo & Co itself, we have 3 different brands. We started back in 2016, and the first brand that we have is called EvoWare. So maybe like more people know about EvoWare. So basically in EvoWare, we provide single-use plastic alternatives using seaweed as main materials. Why we are using seaweed because actually Indonesia is one of the largest seaweed producers, and at that time we're thinking that to create like plastic replacements, of course, like we need to have like the resources that we can take sustainably and is abundant, right? Which is like oceans is actually can provide that resources. And as the biggest archipelago country in the world, we actually have also the biggest seaweed produce. Like we are also the biggest seaweed producing country in the world, and it can actually like we can harvest it like very sustainably. But at the other side, we also see that even Indonesia is one of the largest seaweed producers, but also the seaweed farmers are also like one of the poorest. So what we want to do, we want to have an impact in environmental impacts, creating like the plastic out of like the packaging out of seaweed, but also helping the seaweed farmers here in Indonesia to get like a better incomes and a better prosperity, right? And yes, so the first product that we created is edible cups. It's made of seaweed. And then the second product, 2017, we launched the seaweed-based packaging to replace single-use small sachet packaging that usually cannot be recycled. So basically, both of the products are edibles and can be composted as a like normal like food composting as well. But then like last year, we actually try to diversify our products because we see that there is no such thing as a one solution. We need to come together. So we created our second brand is the rethink plastic products. We have like another like products from like cassava, like industrial cassava that are not meant to be eaten. So it's not like actually competing with like food. And then also like bagasse, like sugarcane leftover, or like rice, like edible straw made of rice, and so on. And we actually have our own campaign also to actually it's called like rethink campaign. The idea is actually we want to create a collaborative movements between like businesses, governments, NGOs, or individuals that we want to actually show that we need to rethinking about like the way we live, the way like we make some things, and the way we do collaborate as well, because there is no, especially in this plastic issue, right? Like there is no such things as a one solution. So we need to combine all the solutions together. Either is like the compostable products, the replacement products, or like reusable products, or even like waste management, like recyclings or upcyclings, right? Because we have like another company is like waste management company as well on that. I think all need to come together, and that's why we created like the rethink campaigns on that. Yeah. So that's basically what we do in Evo & Co. Thank you.
I'm just very happy because it's such a new way of seeing materials that and gives so much hope, and we can not only help the environment while having our lifestyle continue being more or less as normal as we know without making big changes, but at the same time, like it's, to me, it's fun. Like you can even eat your cup when you eat seaweed, which is super good. Okay, so I will start doing some of the questions that I prepared, and some of them might seem like they're a bit repetitive, and I did that on purpose because these kind of issues are new to some of our participants, and I want to make sure that some of the concepts are clear. So yeah, there I go with the first question. In just a few bullet points, how does your products differentiate from others in the market? I know that you just said it, but just like to make sure, why your bioplastic or biocompostable plastic differentiates from oil produced plastics? Would you like to start, David?
Yes, sure. Thank you, Patricia, for the questions. Yeah, so I think what differentiates us is first from the raw material side, because we are blessed with we have a lot of like resources, like natural resources here in Indonesia, right? So like we can not only impacting the like to replace plastics, but also we can try to like we want to impact like the the farmers, especially here in Indonesia as well. So like we were blessed with that, and then like we can actually like play a lot more with the raw materials. We can make like like we can make it cheaper from the raw material itself. That's what like we try to do. That's what we're trying to do. And then as well, like all our products, we make sure that it will actually biodegrade or can be composted in the nature, because I think now there is a lot of like confusion in the world that a lot of like what's called bioplastic is only compostable in industrial composting facility. So we want to make sure that it's actually our products, the products that we provide can be biodegrade in nature on that. Yeah, so I think like that's what will make us different. Yeah, thank you.
Thank you very much, David. I don't know what is happening with this microphone thing today. Thank you very much, Jeff. Would you like to continue? Oh, and before we keep talking, one of our participants highlighted that she's not from an English-speaking country, so it would be great if we can speak a bit slower.
Happy to.
Just saying.
I'll try to keep it at a reasonable pace. The way that we differentiate from petroleum-based plastics across the board is three things. So we are feedstock. First of all, we are bio-derived, meaning that we come from organics. So there's no petroleum involved at all. You don't have to use fossil fuels to make this in any way, shape, or form. We are also bio-benign. Now, that means a lot of different things, but in this case, it means it's compostable. So it can be eaten by bacteria or even animals. I've eaten some just to prove a point. It can be eaten by fish, so it's actually marine degradable as well. So if it falls into the ocean, it will be eaten by algae or bacteria in the ocean. And it's just also make that case, it's certified as a fish food additive. Some PHAs are certified as a fish food additive for aquaculture. So PHA is effectively just microbe fat. So it's entirely organic and it's just grown and it behaves just like a polymer in that sense. So, and then the third one is cost, actually. So we have a negative cost feedstock currently. Now we don't expect that to stay forever, but that means we can produce our PHAs cost competitive or even below the price of petroleum-based plastics at their current rate.
Wow, that's really good. That's really good. John?
Yeah, no, I think I would pretty much just resound what David and Jeff both said is we're really focusing on a green product from beginning to end. And especially when we look at sustainable foams, we didn't see anybody really tackling protection. You know, I think there's good solutions out there right now for some cold chain, for some insulation, but nobody really finding ways to offer that strong protection. And so that performance is a big differentiator for us. But I really think, you know, as both Jeff and David said, focusing on renewable waste streams, really abundant, low impact, not taking more resources and, you know, detriment to the planet, but then a really scalable, green, no petroleum additives, no VOCs, processing technology that's scalable, cost effective. And then for us, we're really targeting compostability right now, industrial and at home, which, you know, is available in really only outside the US. But we also have a potential we're looking at of creating a recyclable, curbside recyclable version of our product as well. And that would be a really big value that we could see bringing to the market of offering a unique solution depending on what customers' end of life, you know, picture looks like, where they are geographically, what infrastructure they have in place as far as composting and recycling. And that's where, as far as cruise foam, I think we have a lot of interesting technology and development in front of us.
Which kind of recyclability would that be?
It would be basically curbside. Imagine cardboard. We are looking at getting high enough paper, PCR, recycled paper content in there that we've gone through the first recycling certification, but now we need to go through the second phase, and that requires quite a bit of volume. And so we're working on it. So we see it sometime next year.
Good. I mean, we have to keep in mind that these are new technologies and companies that you started quite recently. So not all the answers can be answered right now. But thank you very much for your answers. Jeff, I would like to ask you a little bit more about PHA, and where does PHA fit in the realm of bioplastics? And could you dive a little bit deeper on the different types of bioplastics? Because we know that it's bioplastic, biodegradable, bio blah, blah, blah. And it kind of like, there's so many buzzwords, right? That could you give us a little bit of understanding of what are these different types of bioplastics?
Absolutely, and I could talk about this for a long time, so stop me at any point.
Okay.
Effectively, there's a lot of different bioplastics on the market now. The leader is polylactic acid, PLA. It's just the biggest at scale. It's made from usually corn. It's mostly compostable, though there's a lot of back and forth around whether the regulations are appropriate for industrial composting. But PHA, which is a science word, polyhydroxyalkanoate, is effectively a much more compostable organic compound. So in this sense, PHA fits in that spectrum, and I'll talk about how it's made a little bit too, but PHA fits in that spectrum. It degrades in a compost row within, 2 weeks, side of the road, depending on the side of the road, a couple of months, but it can be eaten by all these things. In the cold ocean, it takes maybe a year, but that's just because metabolisms are slower. Things eat it slower in that same sense. So PHA can be used for most of the same things that petroleum-based plastics can be used for. It has, and I make a PHBV blend. There's lots of different co-monomers within the PHA family. So you've got PHB, PHV, all the way up with lots of different chain lengths, and they all do slightly different things. We can make all of those. We focus on PHBV, but what that means is we can replace a lot of different polymer types based on the different co-monomers that we use. So we can replace polypropylene, we can replace polyethylene, and we can replace polystyrene, depending on which co-monomers and which blends we do with green additives. What that means was we're trying to target food packaging. So when you talk about bioplastics, you sort of have to talk about what their end use is. Food packaging, we can do tertiary packaging, all of these things. The things to watch out for are melting temperature, flexibility and strain, depending on what you're going for, all the different technical specifications that have to be in there. But polylactic acid is the main one. Starches are out there as well, as far as green in that way. I'm excited for the chitin and the seaweed, frankly. Those are all really interesting ones that are up and coming. Oh, and PHA is up and coming as well, though it has been around since the 80s. It was actually, they used to make shampoo bottles out of it in the 80s, but they used to make it out of pure sugar. So there's been multiple generations of PHA producers and generations of the technology, ending with we're generation 3 in that sense, where we use waste feedstocks and have an actual cost competitive nature. Cost was always the big problem with PHA. Is that enough of a background? I can dive into any.
I think that for the starters, I think that's fine. Just to highlight one thing is that you have mentioned that PHA is ocean friendly, and I would like to remind our participants that not all biodegradable plastic, compostable plastic, and all these kind of bio, whatever they are called, they are not degradable in the ocean. So as far as I'm aware, BHA and probably the seaweed one, they are ocean friendly. Ocean friendly because they are able to degrade on the conditions of the ocean. So most of them, what they need, and they say like, oh, it's compostable. Yeah, it's compostable, but under industrial conditions. And we have talked about that in previous webinars, but just as a reminder. Okay, the last question unique for you, Jeff, is that Full Cycle says that your technology takes heterogeneous, whatever that word is, my brain is not working today, sorry, heterogeneous waste inputs and produce consistent polymer outputs. How do you do this, and why it is so important for you to close the cycle of your products?
That's a great question. We're very proud of this. So effectively what we have done is we've been able to take the whole world of organic waste by going to its natural degradation pathway. And as it breaks down, all of your big carbon molecules slowly become smaller carbon molecules until normally they'll come off as a single carbon CO2, carbon dioxide, or methane, CH4. Effectively, right before it goes to CO2 and CH4, it goes through the same pathway at the bottom of that funnel, we'll call it. And that is effectively, it's volatile fatty acids. So they're short chain carbon molecules in liquid form. They're basically like smelly stomach acids or a dirty vinegar right before that. And my background is in biological wastewater treatment and anaerobic digestion. And that's what anaerobic digestion does. It takes food waste or organic waste, breaks it all the way down into methane, and they burn it for energy. So basically what we've done is we've gone slightly upstream of that and captured the choke point on that breakdown process. That means we can take cardboard, forestry waste, we can take, grass clippings, we can take mixed food, bread, anything that breaks down naturally through that process. And that allows us to basically have that great homogenizing factor. Everything, we can mix all that together and it all still comes out right through there. We take that and we feed it to a different set of bacteria who eat it and get very fat. I mean, PHA is just a microbe fat. It's very specific in that sense. So there's a lot of science involved, but it really is just capturing the breakdown process and then feeding it to a set of bacteria that will eat it and produce the same thing over and over again. And we can make different polymers depending on how much we break it down. Different VFAs mean different PHAs, and we can control that process very, very directly. And it means that we can take our own PHA in that same process. PHA can go into that funnel and go right back to those volatile acids, which allows us to upcycle it to virgin PHA again.
Okay, and did I understand correctly that you break out the phase of producing methane?
Yeah, there's no methane produced. We stop it from doing that. I used to be in the business of producing methane to burn for energy, and it's very easy to upset those systems, as it turns out. There are lots of stories I could tell you.
I think that this is highly important and to highlight, because methane is one of the most dangerous causes of greenhouse gas emission. I have no idea what happened to me today. I'm sorry. Yeah, so it's really important that you have phased out that of your cycle. So congratulations. David, I would like to pass and do some questions to you. Why I know that you have pitched it before in the introduction, but why I would like to know more about why you decided to make new plastic-like products from seaweed. I think that that's a genius idea, and more having it local, that being able to produce it locally. But seaweed is something that people don't really get so interested about it, but they are super relevant for our ocean. So please.
Yeah, thank you, Patricia. Yeah, so basically, it started quite strange. because I actually don't have I don't really have backgrounds in like chemicals or like biotechnology or even like food technology. In fact, I actually like high school dropout. But like when I started the company, like the first idea is actually to raise awareness about like people, like to raise awareness for people about this plastics issue here in Indonesia. So I was thinking that the product need to be unique and different, and so that like people can actually like see the product itself and that it's different, and then like they're curious what like you know like about the products, and then like we can actually like explain raise awareness more about like the plastic issue. So the first idea is actually to create the edible cups that but at the time like I didn't know what's the like how to make the cups or even like what the cup is gonna looks like, right? But like the simple things is actually quite simple. So like we want to make it first, maybe it sounds like very simple, and but first it's just like like I want to make it like jelly cups, because jelly is very easy. It's just like need moldings, right? And then just try to use it. But actually I found out that jelly is usually made of gelatin, and I think it's not really sustainable because it's made of animal bones, right? But like when I actually like we are fairly blessed now that we can all study it from Google's, right? Like all the information is there. We can study everything in the internet. So I found out as well that like jellies can made of seaweed. And then like from there that I know that Indonesia is one of the seaweed producers, and then the way we harvest the seaweed is also very sustainable. It doesn't need like fertilizers. It can be harvested in 45 days, and seaweed not only can be food for the fishes, so it's the whole ecosystem will be there, but also seaweed absorb carbon dioxide and also releasing oxygen. In fact, like 70% of our oxygen is coming from the oceans, and one of it is coming from seaweed as well. So I thought that that is like really great, like resources to make like plastic replacements, and then like study more about that. Then like I also like meet like a lot of, now we have our own research and development teams. We also collaborating with other companies or even like other university or individuals to actually like do some research about like seaweed and the other materials. But we are focusing on seaweed is actually like because of that we see that we can give a good impact not only for the environment, but back again we also see about like the social value that we want to bring to the seaweed farmers and the coastal communities as well here in Indonesia, and can be also like to other countries like Malaysia or like other like Asian country, or maybe we can later on go to another part of the world. Yeah.
Again. That's so great. That's such a great idea, and the fact that you're saying that you did not go to university and study all of this, but every time you can find it in Google. I think that's wonderful and very inspiring. Okay, the second question that I would like to the second topic I would like to touch upon is that during the documentary of Story of Plastic, which was the first expert panel that we had back on September, we learned that sachets are among the most problematic single-use plastic products, especially in countries from Southeast Asia, because sachets are widely used and because their recyclability is very low. How did you come up with the idea of making something that is not only environmentally friendly, but also that it's edible, as we were saying before? Why you wanted to replace something as a sachet that's such a big problem, and you can actually eat it, and you pour. I love that video when you pour boiling water and it disappears, and it's part of the meal.
Yeah, so actually like actually our seed-based packaging it dissolves in the water and it's edible as well. So like the idea, so the one that created the seed-based packaging actually like my colleague, her name is like Noriawati. She's been working on that since 2011, I think. Then like when we created when I created the company, I helped to actually like launch the products and spread the products as well up until now, right? So the idea actually when created the edible cups or the edible seaweed-based packaging, it's just we want to show people that it is very safe, even human can eat it, and then also to show how actually like seaweed or ocean farming can be also like the future of the farming. Either it's going to be like food or packaging or like anything else, because we already like destroyed a lot of in the land, if like land-based products, right? So that's, and then like we make it edible, yeah, just because we want to show people that it is very safe, even human can eat it. And then seaweed also have a lot of like nutritions, so it can so when we use it for like for example, I think like you see on the video, we're using it for instant noodle seasoning. So you don't need to open the seasoning, you can just like put the hot water, and then instant noodle itself is not very healthy, so we can put like additional nutrition on that. So yeah, but we don't necessarily have to eat it because it's packaging, right? It's need like the main actually purpose is actually to protect the food or protect what is inside, right? So but yeah, we just want to show people that it is very safe, that even you can eat it. Yeah.
And do you foresee that these sachets could also be useful for shampoos? Or when I was in Bali, I saw that they, and Africa, I see that they sell alcohol beverages in these sachets, and they were everywhere. I went to La Boma Beach in Ghana, and it was horrible. Not in La Boma Beach, the one close to, because that is clean. So do you foresee that you can use these sachets for shampoos or alcohol instead in the future?
Yeah, in the future, like hopefully like can, but at the moment like we still only using it for dry products because it's still like dissolving the water. But in the future we can put like maybe like another layers of coatings, or like the formulations we can change. Yeah, that hopefully can do. Yeah.
Okay, thank you very much, John. Finally, sorry, I had you waiting for a little while.
Good.
I think I will go straight to the point and ask you, like, what are your phones made out of? Because it sounds so cool, and it can take away so much packaging, plastic packaging, oil-based packaging.
Yeah. So it's made from a couple of different sources. Like I said, we combine different waste streams, but definitely the kind of key technology, if you will, is the ability to take this abundant biopolymer, called chitin, the second most abundant on the planet after cellulose. And why we focused on chitin is not only is it so super abundant, but it has really fantastic mechanical properties that it exhibits naturally and how it polymerizes. It essentially really helps make crab, lobster shells hard. And so using that really kind of high strength weight ratio, that's what we look to harness when we manufactured and created our foam, cruise foam. And what we saw is it allowed us to create very high performance, strong protection foam that could rival an EPS at the same time, a cost structure, the same type of manufacturing. And the chitin itself, we get from a number of different sources. As I said, it's the second most abundant. Historically, the most comes from crustaceans, shrimp, crab, lobster. There's about 10 million tons of just shrimp shell waste that goes either into landfill or back in the ocean, which can be very harmful. And so there's a very small industry that was actually kind of created around the 80s around sourcing chitin. Everybody thought it would be the next cellulose, but people didn't really figure out how to use it or kind of process it very well until I would say the early 2000s. And so there's a lot of opportunity where I would say only about a percent or less than a percent of this chitin waste is actually sourced and used. And most of it is for research or high-end application. Nobody's using it on an industrial grade. And that's where we saw the really strong opportunity. And right now we get a lot of it from Indonesia, ironically enough. That's one of our biggest suppliers are, but it is a global supply. And that's what's really encouraging. We're seeing growth in the US, we're seeing it in Mexico, we're seeing it in Europe, in Australia. And it's not only from shrimp. We're seeing it also start coming from insect farming is a big source of chitin, and also fungus. There's a lot of new sources and a lot of new companies popping up around byproduct waste from those industries around getting the proteins from insects and whatnot. So we're really seeing a global supply that's diversified that we can then combine, like I said, with recycled paper, starches, really allow us to control the cost and the performance of the foam for what the customers might need.
Great, great. I'm working now at the university in researching about seafood industry and farm and aquaculture, and I can tell you that that amount of shrimp is not natural. So I'm afraid.
I know.
So is not like some people can say like, yeah, but shrimp shell, it's something that belongs to nature. Yeah, but not in that amount. I don't think that could be great.
I agree, and
it's a lot.
It's enormous. It's enormous, and that's what we've seen. You know, we don't see any need to shrimp or farm more. And honestly, we're really trying to position ourselves to work only with ethical people, only with ethical businesses, and really have a lever or a position where we're adding value to that side of the market and seeing it become, you know, cleaner and more, you know, more valuable for the people that are trying to source these waste streams and trying to find valuable product for the waste that they're coming from that marketplace, and really kind of being a double-sided benefit, not only to the packaging, but also to hopefully the shrimping industry and cleaning it up and seeing how we can benefit that side.
Having a full cycle and sustainable ways of producing new products. So that's
exactly.
Great. Okay, second question. Cruise Foam makes new products from materials that otherwise, as we just said, end up wasted and most likely back in the environment, as we just said. Yep. Could you tell us more about the product end life and how your product is zero landfill? Because I was hesitating a little bit when I was researching about that, and I was like, I want to know how you make this happen.
No, for sure, that's a good question. And so I touched on a little bit earlier, but we're really achieving zero landfill by looking at providing end-of-life solutions that are customizable depending on where it's being distributed, where it's being sold, and where it's being trying to be disposed of. And right now, we're definitely focusing on compostable. It can be an at-home. We're going through the certification process, but it can empirically, and we've tested it can be at-home composted. We know it can be industrial composted. We assume it can be marine composted. Most of the stuff is either bio-based or it comes from the ocean originally. So we haven't gone through that yet, but we anticipated not having issues going through the marine environment. But then definitely, as I said, looking into the next year, we want to try to make, and we're in development of making recyclable product. And so really looking at zero landfill, we want to offer solutions that remove any necessity or any necessity to put waste in the garbage. It can either go in recycling, it can either go in composting bin, your green bin at your home, you can crumple it up, put in your garden. And that's really how we're trying to approach this, is offer solutions that completely avoid any end of life that approach the landfill, and ideally have benefits to end of life. As far as chitin itself, it's actually a fantastic fertilizing material. It fixates nitrogen. It would be a really beneficial end of life in the composting environments right now, especially in industrial composting. And that's where we see this really not just having kind of a dead end of life. We really want to see it really adding nutrients and adding benefit in its death, really having that full cycle where we can come back and see, you know, growth in other areas and other markets and other areas that we think would really need it, like agriculture. And that's where we see a lot of benefit in our zero landfill approach that we're looking to take.
Good, thank you. Okay, I would like to remind our participants that if they would like to ask our panelists some questions, they should do it on the chat, not on the main one, but like in the, how is this called? The Q&A chat. I think that we had 2 different questions, but I think that we have answered them already, right? So if someone wants to know more about these 2 questions, just let me know. Otherwise, I will continue with the ones we have.
Patty, can you hear me? I have a question.
Okay.
So
Good.
Yeah. So first, I want to thank all the panelists for sharing the details about their solutions. They've been really, really enlightening and inspiring as well. I think that this whole, what I find common between your 3 solutions, even though they make very different, you know, sort of target alternatives, is that they come from a point of view of like, okay, but what resources do we have already that are not being used adequately? Or, you know, in the Indonesian case, at the start, it was, well, seaweed farmers don't, you know, in Indonesia in particular, get really low commodity prices. What can we do? You know, that might be an opportunity. I think this is a kind of thinking that we talked about in our previous Unmasking Plastic on circular economy and circulating plastics. And I think it's an essential mindset that we need to have. It's the only way we're going to have, any kind of sustainable product is if we're thinking about end life really intentionally, and we're thinking about what is out there that's not being used but is abundant. So I really love that. I hope that our attendees take that mindset if any of them are working on production. And then my question is, one of the reasons we all love plastics is because it lasts a really long time. And so I'm wondering, and maybe some of our attendees are wondering, what are your products like? How do they compete with regular plastic on that regard? I'm sure like the seaweed, for example, has a particular shelf life. Jeff, you mentioned sort of temperatures. So yeah, what is that competitiveness, and is that a problem? Yeah, I'll leave it there. That's for anybody, so you can just start talking.
Yeah, so from now on, the questions are for any of you, and if you three want to answer it, that's perfect.
I can jump in. I can jump in maybe first. And so looking at the end of life and kind of lifespan, if our product cruise foam is in soil, if it's in the right environment, composting or honestly your garden, we've seen it decompose in less than 6 months, honestly closer to 2 or 3. And that's only if it's in the soil. It needs the enzymes, it needs that wetter environment. We have foam that we've made 2-3 years ago that's on the shelf and it still performs. It's still fine. And so we don't see any long-term degradation in a normal kind of storage environment. That being said, our foam is clearly designed to be single use, and the idea that we want to remove the EPS and the other harmful plastics. So from that viewpoint, obviously we're not targeting a reuse model or anything like that right now. But I think there are opportunities for other technologies that could fit into that, and for other harder plastics that maybe have those type of applications.
Yeah, I'll go next. On our end, it's really interesting. We can put our PHA into an environment where it's eaten readily. A compost row is probably the most active environment. You see maybe an anaerobic digester, and then it's gone. An anaerobic digester is gone in a week. The compost row is gone in 2 weeks. But it can last on the shelf for 20 years. I have generation 1 PHA sitting on my shelf that's from the old people who made it out of sugar, and it looks just like it did then. It gets a little bit more brittle over time, but that's over the tens of years scale. There really aren't a lot of bacteria eating things on the shelf. So it has a great shelf life and a great narrative in that sense. The only time it really degrades, and this is why it has such a different degradation period over the different environments, is when it's eaten. You can break it into smaller pieces and then it becomes more bioavailable. For example, if you had a bowling ball made out of PHA, it would degrade outside in. It would take a long time for the middle to get there, because what's going to eat it if it's sealed away? So it's important to note that, but really there really isn't a shelf life issue. It's more of a environmental issue.
And
yeah, I think I'm definitely agree with all of John and Jeff questions. I think there's already hello, can you hear me? I think it's a little bit okay. Yeah. I think there's definitely the answer. There's same with with our product as well. When it's shipped in the shelf, there's not really problem. So it will actually degrade or biodegrade or compost when it's eaten by bacteria or microbes or with waters, right? But I think we need to also not only from the producers or plastic perspective, but I think all the audience here also need to actually understand from our our lifestyle, the way we are thinking, because most of the plastics, for example, straws or shopping bags, plastic bags, is you're only using it for 10 minutes, 1 hour, 2 hours, and then you actually throw it away, and then it will sit there for hundreds of years, or even thousands of years, right? So I think there's actually also like the mindset behind we created like the Rethink campaign is actually we want people to actually rethinking about the lifestyles, not only like we are producing plastic, but not only like from the producers, but also from the consumer side, that we need to consume responsibly, so if you don't need it, don't use it, and then like if you can have another alternatives, then use the other alternatives. But if you ended up like using like plastics, you can recycle it or upcycling it, but that's actually like we need to rethinking about that we like every individuals is also actually responsible on like what happened, not only in the business side or like producers or like whatever, but we as a consumer, I think as individuals need to also like understand. I just like want to say about that. Yeah.
So that is what we have been saying over and over and over during the whole series. We have to think here about system. It's the whole system. We don't need to change only the material. We don't need to change only how we're doing policy. We have to see it everything from a holistic point of view and interdisciplinary way. When we touch upon many different things at the same time, so we can create effective change. So thank you very much. I'm liking it so much. Thank you. We have 10 minutes left. I did not receive any further question from anyone, so I think that I might do the last question.
Patty, we do have 2 questions in our Q&A.
Yeah, but I thought that those were already answered in the way that they have been.
I don't think the second one was, but I don't believe the first one has really been answered. No.
Okay, go for the one that you think that is not, because I cannot.
So Subramanya Subu, one of our Young Ocean leaders, has he actually works has his own company doing with recycled plastics. But he's asked, why is there skepticism towards bioplastics rather than companies jumping into this opportunity? And he puts in parentheses, apart from the oil-funded media, of course, we've talked about on this series. So yeah, maybe from a more technical commercial side, why is this like? Why are your ideas not? Why do we still use plastic and not your products everywhere?
I'll start. Sure. It's a good question, and it's always interesting to see. So as we go about on the commercialization path, it takes a tremendous amount of volume, and it takes a tremendous amount of buy-in from companies. And there's a bit of a chicken and egg problem when it comes to these things. Everyone wants to see it working at scale before they'll invest lots of money into it, and investors want to see commercial traction before they'll put significant dollars to help prove it out. So there's a whole bunch of reasons why it is really hard to get a new technology to scale to actually be able to do this and then adopt. On top of that, there's also recycling industry entrenched value, where people want to see the recycling industry pay off in the way that they've already invested in, because they were sold that as the great way to solve these problems. But on the upside, I mean, and of course, petroleum is an interesting one. Everyone is starting to realize now that these things do need to be solved in multiple ways. It takes a whole palette of materials to actually do these. And there are large companies, I mean, I work with several, it sounds like John, you do as well, that are investing in this. They don't like to roll it out entirely until it's been entirely de-risked. And with all the different technologies, there's so many different fits, and some have great strengths in one area and weaknesses in another, that it takes time and fit to roll these things out in a big commercial way. But it's coming. Many of the companies that are in situations like us are growing and getting commercial traction. And then it just takes time to get to volume, and then policy, and then all the things that come along with it.
Thank you. Do you, John or David, want to mention something further about this question? We have 7 minutes left.
Yeah, John, you want to say something first, or me?
I can follow up on what Jeff said real quick.
Okay.
I think what he said was spot on, like nail on the head. You couldn't put it any better from what he just said. It's a total chicken and egg game right now. What we're seeing is, on top of that, you'll definitely have the early adopters, the larger kind of Fortune 100 companies that we're working with that have they still use an enormous amount of EPS, and they see the writing on the wall. So they're willing to take the bets a little bit earlier, invest, and try to get ahead of the game before the regulations start popping down. But I think one of the other things of why you see hesitancy or skepticism is, I think Jeff kind of touched on it, recycling, petroleum. I think there's been a lot of materials that have tried to be introduced into the market. I won't name names, PLA, that haven't quite lived up to what they said they would. And I think what's been difficult is you have this industry that feels they can't rely on what they're being told. And they try to implement this, it screws up the system. I think there's some strategy behind this from certain players in the industry, you could say, to cause this confusion. But I think that's why you see a lot of these hesitancy from large brands or from the industry really trying to dive deep because they don't want to get burned again. And I think that's on top of what Jeff said, I think is another component we're seeing play.
Mm. Mm.
Yeah.
Thank you for adding, David.
Yeah, I'm totally agree with John and Jeff as well. Like that's exactly like what happens. Like first, in terms of the scalability, like the to make it like mass productions. I think when we doing like research and developments, there's like one thing we can do. Like in the lab when we do research and develop R&D, I think we can create like whatever like we want to create. But the question is whether we can actually like bring those like inventions or those like research like to the like commercial side, right? I don't know. I haven't really studied about like the plastic history, like how is it made at the first. I mean like how it's actually like take over like the world. But like I believe like when plastic is the first time created as well, it's not gonna be like like 1 year, 2 years, 5 years. Suddenly like all over the world they're using plastics. It takes times, right? I think like plastic was the first like commercialized back in the 60s, right? So it's been 60 years now. That's since like plastic first created. So it takes times, and then like it takes a lot of like money, resources. Especially John was mentioning as well about like the confusion. Now we have like these confusions about like PLA or like on the other like bioplastics that are actually like kind of like greenwashing. That also can make like other people like confused first, like either like they don't understand about it, which is like I think like most of the people like now like they don't understand about it, or like they just want to look green, so they already know that it's not like very it's not like really like green products or like biodegradable products, but it's just because it says it's biodegradable or compostable, and then like they just want to use it, so that make the companies look good. And then on the other side, the regulations or there is not really like a standard about like that, right? So I think now still a lot of like confusions, and then like times resources that need to put actually to for this issue. That's what I think. Yeah.
Okay, good. Thank you, Ron. I know that John, I think that you have to leave at 7 spot, right?
Yeah, I do. I gotta go downstairs.
So we have 2 more questions from the panel, but I think that maybe we can try to answer them on email. What do you think, Ron?
So why don't we close things
Because-
out? I'll just ask our panelists to provide, a final closing remark. And if Jeff, well, it's quite late for everybody actually. So
yeah, David, thank you so much. Like this is so late for you.
we will take your questions and ask the panelists to send us any kind of response they might want to give.
Yeah.
And include it in the file now that you all get. So back to you, panelists.
Yeah. Also, I would like to remind the panelists that we are putting together a library, plastic pollution library, about all the topics that we are talking about. So if there is any kind of reports or information that you would like us to pass to our attendees, please do so. So you can send it to me on email, and we will pass them to them on our community. So yeah, sorry. Just before I was forgetting about that. Some closing remarks from our panelists.
I'll go first since I have to jump off in about a minute. again, just thank you. I think this has been fantastic. It was great to hear Jeff and David. I think the biggest thing that I would take away from this is, honestly, they both said it, and I would just like to reiterate it. This is going to take multiple solutions. It's going to take multiple technologies, new innovations. Industry is going to need to support it. They're going to have to. And I think what's really important is we see the change happening. And I think what's really important is that we make sure we identify the good solutions and really push them into market where they're going to be most effective to end this horrendous plastic pollution problem we have going on. So thank you again. I got to take off, so I appreciate it.
Thank you
Thanks
very
so much,
much
John.
for making time for us. Ciao.
I'm happy to go next. Yeah, I would mirror that. It's been great to be here with all of you like-minded folks and mission aligned, and everyone's so eager to learn about the issues and the problems and start getting into the solutions. So really appreciate the time. Overwhelming hope coming up here. I mean, while the problem is continuing to get worse, plastic production is spiking, all of these things are happening. That's all because it's very, very useful. Plastic is a very useful material, and that need doesn't necessarily undercut us in this. The bigger, and the problems will get bigger, but the bigger the problem, the bigger the solution. And more organizations, whether they're for-profit or not for-profit, are getting into this and starting to put weight behind it. So the momentum is coming, and this is a good proof of that. So all of these things will continue to grow, and we will see a change. The old saying is the bio revolution will be to this century what the industrial revolution was to the last, or the petroleum revolution. The biorefinery and the oil refinery being those.
Good. Thank you very much, Jeff. David?
Yeah, thank you so much, like everyone. It's also a pleasure to be here, especially if there is any of you guys from Indonesia. I'll be like amazed. It's past midnight, and then like you listening on this. I think that's really great. Or like the other part of Asia that already like midnight, or near midnight maybe. I think that would be that's really great. I can see the enthusiasm on that. I think Jeff and John's already said more into our business perspective, right? And then but I want to say more for the individual perspective, that actually there's a saying also that never feel that you're too small to make a change. There is the quote that I read last time, that is don't think it's actually for example straw, right? Don't only think it's only one straw, but but 7 billion people said it's only one straw, is becoming 7 billion straws, 7 billion plastic straws, right? So so small things matters, and I think as individuals we'll need to actually responsible of our own also actions, right? So don't always blame the plastic, as Jeff mentioned. Plastic is very important. We have our different part that we need to play, or different roles, right? In this side now we try to do make the alternatives, but also in the individual side, consumers side, as a consumer we need to also be responsible on that and be mindful and be thinking actually in the way we live on this earth to make it better. Yeah, I think that's all for me. Yeah, thank you.
Yeah, thank you very much. I learned so much tonight, and I love doing that. So thank you very much, and also for the times you're here. Once again, I know it's not easy, because I don't know, for Jeff, I think for you it's early morning, and for you, David, is late night. So
No problem.
I really appreciate that you take some time of your busy working days to come and do something for us. So Ron, would you like to say some?
Yeah, I'll just say thank you guys. And for our attendees, we'll be back in 2 weeks. And we'll be talking about cleaning up plastic and monetizing it from trash to gold. So we will see you all in 2 weeks' time. And with that,
and remember that you can watch this again on Facebook and LinkedIn or something. Oh, YouTube. Yeah. Okay.
bye everyone.
Ciao, ciao. Bye.
Bye now.
Bye-bye. Thank you.